Okay, I want to talk about matrices. A matrix is a two-dimensional array of objects or elements. So it can look something like this. Excuse me, that's my washing machine. So this is a 2 by 2 matrix. A vector is a special case of a matrix that only has one column. Obviously a vector is many more things than that, but that in this, for intents and purposes of this video, that's what a matrix, what a vector is. So we can define matrices. Usually we define them in much the same way as we define other things. So if we have a matrix A, it equals some elements in here. And we can refer to those using this kind of notation. So the first, this is obviously the small letter of the name of the matrix here. So this is the small version of the letter, and then we've used 1 and 1, so that's the row and the column. And then here we have A1, 2, so row 1, column 2. And then obviously if we come down here, we'll have 2, 1, and A2, 2, and so on and so forth. And these are generally conventions, so that if you see them, you're not confused by them. Okay. So how do we perform operations on matrices? Well, if we have, if we want to add them, they have to be the same dimensions. So we have to have the same amount of rows and the same amount of columns. So if we have matrix A and matrix B, we want to add or subtract matrix B, we can, because they have 2 rows and 2 columns, and that's equal. And we would do that directly. So 1 plus 5, 2 plus 6, giving us C, if we were adding it. Giving us matrix C, if we were adding it, which would be 6, 8, 10, 12. Okay, multiplication is a little bit more complicated. If you want to multiply, the columns in A must be equal to the rows in B. And that's the only rule for whether they can be multiplied or not. So the columns in A, it's a two column matrix, have to be the same as the rows in B. So it would have to be a 2 row matrix in order for this to work. So how do we make matrix C? Well, you have to take then the rows here and cycle through, for each row in matrix A, cycle through the columns of matrix B. So you would do for C11, you would do 1 times 7 plus 2 times 9, giving you C1, which is 1825. For C2, for C1, 2, we would do 1 times 8 plus 2 times 10, giving you 28. For C2, 1, we do 3 times 7 plus 4 times 9, so 21 plus 20 plus 36, giving you 57. And then for C2, 1, you'd have 3 times 8 plus 4 times 10, and so on and so forth. And that's multiplication. In the next video, we're going to look at finding the inverse. So I just want to talk about what an inverse is in this video, and then we can move on to more complicated operations with inverse in the next one. So a matrix only has an inverse if it's a square matrix, if it has the same amount of rows as it does columns. The notation, the inverse of A would be written a to the minus 1, very much like in algebra. I don't know why that's not giving me that. There you go. The inverse of A is a to the minus 1. Just a few conventions. A matrix times its inverse gives you the identity matrix. The identity matrix being this for a 2 by 2 matrix, or this for a 3 by 3 matrix. And you would just keep going with that diagonal ones if you were to grow it any bigger. So back to the inverse. Matrix B is the inverse of A if A times B is equal to B times A. So if A times B is equal to B times A, B equals the inverse of A. Just going back to the identity matrix, A times the identity matrix is equal to I, the identity matrix times A is equal to A. I times A equals A times I equals A. So in the next video, we're going to talk about finding the inverse. But first thing we need to do is figure out whether it has an inverse or not. So we use something called the determinant. Now, you may be familiar with the discriminant in quadratic equations. Now, while they're not related as such, it's a similar idea. In a quadratic equations, you can tell by the result of the discriminant if your quadratic equation has real roots and how many. In matrices, if your determinant is equal to 0, there is no inverse to your matrix. So if the determinant is not equal to 0, then the inverse matrix, and A can be any matrix, exists. So we'll start with a really simple one. If A is A, B, C, D, the determinant, getting confused there, determinant of A is AD minus BC. So if that is not equal to 0, then we have an inverse to our matrix. It gets a little bit more complicated when you get larger matrices. So if you have A, B, C, D, E, F, G, H, I, remember it has to be a square matrix, then what we have to do is A times the determinant of E, F, H, I plus B times the determinant of D, F, G, I. Then it's C times the determinant of D, E, G, H. And you add those sums together, and if that equals 0, then there's no inverse. Like I said, in the next video, we're going to look at calculating the inverse of a matrix. But I think that's quite enough for one video.